In this video, we'll be going over the bottom-up 2D matrix approach of triangle. Let's go over the thought process. So let's convert the top-down memorization approach to a bottom-up approach. Now, where do we start? In the memorization approach, we have cached RC with the minimum path sum. So min sum. This means we can create a 2D matrix, min sum, to keep track of the minimum path sum for all combinations of RC. Now, what are the default values inside the min sum matrix? When R is at the last row, we only have one element left. This means we can place the last elements at min sum RC. Let's go over the pseudocode. So we're going to create a 2D matrix, min sum, to keep track on the minimum path sum for all combinations of RC. Then we're going to iterate through the indices from triangle.size -1 to 0, which means we're iterating through the columns denoted as R. Then we'll iterate through the columns from R to 0, denoted as C. We're iterating from R to 0 because if we're currently at the 0th row, the last column is equal to 0. And then if we're currently at the first row, the last column is at index 1. And then we're in the second row, the last column is at index 2. Because this is a 0th row, 1 and 2 and then 3. And then if we're at index, this is currently index 2, so the last column is also at index 2. Now we want if R is equal to the last column, or the last row. This means we only have one value left, so place triangles dot get R dot get C at min sum RC. Then we can continue to the next iteration. Then we want to pick the smaller value. Pick the smaller value x between the min sum of going just downward, R plus 1 and C, and min sum are going downward and then also to the right, min sum R plus 1 and C plus 1. So basically, we're currently at this cell. We want to pick the value here or here. We just want to pick the smaller value between the two choices. Then we want to place x at the current minimum sum, RC. Then we can increment min sum RC by the value of the current cell to account for the current cell, which is triangle.getsR.getC. Then we can return min sum from the 0th row and the 0th column, which basically from the top, because we're going from top to bottom. And then what's the time and space complexity? The time complexity is of n squared, or we should say m times n, where mn are the number of rows and columns. Or we can just say n squared, where n is the number of rows. This is the nested for loop. And our space complexity is also n squared. This is our min sum matrix. Now let's go over the code. So we're going to create our matrix min sum to keep track of the minimum sum for all combinations of RC. Then we'll iterate through the rows, starting from the last row. Then we iterate through the columns, starting from the last column of each row. Then if R is equal to the last row, we only have one value left. So we just place the one value at RC, min sum RC. Then we can continue to the next iteration. Now we want to pick the smaller choice between going downward to C, R plus 1 and C, and also going downward and then to the right, so it's R plus 1, C plus 1. So min sum RC is the minimum value between going downward, min sum R plus 1 and C, and also going downward to the right, min sum R plus 1 and C plus 1. And then plus the value at the current cell. So it's triangle.get RC. Now we want to return the minimum sum. We start from the top. The min sum 0, 0. Let me know if any questions in the comment section below.